Hi, I'm Tom Boyle, and I'm going to show you how to find the resource leveled longest path in a Microsoft project schedule using BPC logic filter. This is an example of a Microsoft project schedule that includes resource loading, but not resource leveling. In addition, the project schedule does not include any soft logic links or preferential logic links that are sometimes used to govern mobilization and deployment of resources in different areas of a project. So, what's common in some industries is to use the resource leveling in Microsoft Project. So, we have a leveled schedule now where a number of tasks have been delayed according to the leveling engine in Microsoft Project. A leveling delay is included in this column here, basically in elapsed days. What the schedule tells us is that the project starts with the notice to proceed, and then Area 1 Civil Works proceeds, and you go through a combination of logic links and resource delays to finally end up at a substantial completion date that is 2 weeks late compared to the deadline. If we're trying to recover that 2 weeks of delay, we need to find where's the critical path. What activities do we have to shorten? Unfortunately, in addition to resource leveling, this project schedule also includes variable calendars and, of course, a deadline. And these can affect the usefulness of total slack. So what total slack tells us here is that only the red bars are critical, and that the first critical task in the project is this second one. And of course, we don't trust that because we know that this task was delayed because of this one. So I'm going to use BPC logic filter to try to find the longest path, and those will be the activities that we can focus on to try to shorten the overall project schedule. I'm just going to use default conditions here. Now what you find when you run the longest path filter, we go from notice to proceed to substantial completion with a nice chain of activities, all organized according to the original outline structure of the project. But what you see here is this chain of activities has big gaps in it, and these gaps correspond to the leveling delay that is assigned to each of these so-called critical tasks. So let's redo the longest path filter, but this time let's check resource leveling drivers. Aha, we get a slightly different picture. Now we have these resource drivers that have been added into the project schedule or into the longest path, and in fact the longest path has actually been changed a little bit. We can't really see it in this view, so let's look at a different view. Let's show this in line in the overall project. Okay, so now what you can see is that the longest path, the resource leveled longest path, is colored, and the resource leveling drivers have this cross-hatched pattern in them. At any rate, what you can see is that our driving path with resource leveling in place follows this pattern. What you can also see is that total slack is not a very good indicator of where the longest path is. Let's look at near longest path. I'm still going to check for leveling drivers, but in a near longest path view, I'd like to resort to show the logical branches to see how the different tasks and their logic relate to each other. Okay, so now it's a clear picture. Here is the resource leveled longest path in one continuous chain of activities, running through the resource drivers in several places. The task that Microsoft Project said was the first critical path task is down here 10 days removed from the driving path. There are a number of other activities that are also 10 days removed from the driving path, including these that are all controlled by resource leveling delays. So that's our longest path and our near longest paths in a resource leveled schedule.